Hello everyone, welcome to THINH Group 4. I would like to present the back-end implementation of the smart campus system, while the personal feature like booking and scheduling are important. Today I will focus specifically on the non-personal requirements that make our system production ready. With following the project specification, we have agitated our back-end to satisfy 5 critical pillars. First is security. Based on the section 3 and answer 2 of the specification, we implemented 3 switch layers of defense. First is access control. We enforce role by access control or PIC via GWT. In order by the system verify the active user. We strictly separate role. For example, a student account is easily blocked if they attempt to access lateral or admin only endpoint like via booking. The token generate logic in here. Security by for ensure these lamps are cryptographically signed using SS.256. Second is data encryption. Here's some function for encrypt and decrypt booking data. To strictly satisfy the requirement of securing all booking information, we implemented field level encryption using SQL Academy event listener. Here, sensitive field like the booking purpose or cancellation reason are automatically intercepted and encrypted before they are written to the database. They are only retrieved when received by an authorized user, ensuring data confidentiality even if the database is compromised. Finally, input validation. To prevent attacks like SQL injection or XSS, we have some function for sanity input. We build a robust sanitization engine. In this function, sweep enter the control character and escape HTML entity. It also actively detects and blocks common SQL injection pattern before the data is ever processed, ensuring complete system integrity.
We walk you guys through the reliability aspect of our project. So to focus on ensuring the system is robust, testable, and recoverable. Reliability isn't just about the code working once, it's about it working consistently under change and traffic. So I have approached it to 3 pillars: automated pipelines, data integrity, and runtime stability. So the first pillar is CI/CD and testing. First, to prevent bugs from reaching the production, I have implemented a CI/CD pipeline using GitHub Action. You can see here, every time the code is pushed, it automatically spins up a Postgre container and run our test suite. You can see here we check the backend by run the test, wait for the Postgre. For the front end, we ensure that the code is compilable and we can run the code. Also for the integration, we will ensure that the backend and the front end can both deploy by Docker and can test through the API. This is our simple test, like we check for login, run backward on login into a non-existent user. For the second pillar, we will ensure that data integrity and it can be recoverable. So data loss is a major reliability risk. To mitigate this, I have wrote a backup script using a Postgre. I went to a step further and integrated it into a pre-commit hook. This means the system automatically attempt to backup the local database state before allowing to commit, prevent accidental data loss during development. Also, we also have set up a ambemic here to ensuring that database schema changes are versionized and can be upgraded or downgraded safely without breaking the application. For the third pillar is runtime stability. So finally, to protect our API during the runtime, I have implemented a rate limiting middleware to prevent abuse like brute force attacks on login endpoint or spamming booking requests. This could crash the server. You can see that I also set up a health check care, Docker health check for a dedicated endpoint. This allows our container orchestrator to automatically restart the service if it ever becomes unresponsive. So in conclusion, by combining automated testing, automatic backups, and runtime protection, our project is designed to be resilient and reliable for production use. Thank you for listening this.
Next is availability. So I want to highlight 2 major implementations to our system availability. First is the database failover. We utilize a serverless Postgres database, which means connections can become stale when the database scales down. We solve this by enabling proofreading. This allows our application to automatically detect dead connections and reconnect instantly, ensuring users never see an error just because the database was waking up. Second, we transform our heaviest endpoint, the room schedule. Generating the schedule requires complex data math and heavy database join. To fix this, we implemented a read-through catching strategy. We check Redis first, and if it's a hit, we return data instantly. If it's a miss, we compute the schedule and store it for 15 minutes. This drastically reduces load. Crucially, we designed this to be fail open. If Redis ever goes down, the code simply falls back to the database, so the system never breaks.
So for maintainability and repairability, we have secret management. So it means we don't leave the environment variable in the code, but we separate it into a separate .env file. And of course, we won't upload that file to Git or anywhere else, and we keep that as a secret. This is an env file example. And we don't hardcode this thing into the app. And later we will invoke them by calling the file in the setting or anywhere else that is needed. Moreover, all the pages are separated into many folder and many repo for easily to update and edit it. As here you can see, we have separated each folder into each function separately, and we separate backend and frontend. Also, we have different branches to easily to manage and update the app.
So now I will talk about the scalability of our project. So first we will talk about the condition pooling. So for this one, in this system, condition pooling is managed automatically by SQL RGB through the asynchronous engine. A pool of reusable database connection is maintained, allowing API requests to share the connection instead of creating a new one each time. With a pool size of 10 and control overflow, the system efficiently handles concurrent requests and traffic spikes. Connections are returned to the pool, and after each request, and pool creeping ensure connection validity, improving reliability and performance. Also, that we also have the stateless authentication. So, it's using JWT. Upon successful login, the server issues a site access token containing the user identifier and expiration time. The server does not store session state. Instead, each request carries the token, which is verified through the fixed signature and expiration checks. This stateless approach improves scalability, reduces server-side memory usage, and simplifies horizontal scaling. So now we move to the demo part. So first I will sign in for the teacher accounts. Okay, so first I will check. I already have two new bookings here, room 4, room 305, and room 401 from this current tab. Okay, now I will go back to the tab table. You can see here, this week we have already booked it. So now I will try to book this room and this, and I will say demo, the purpose of demo, and confirm it. You can see it tell me it successfully booked room 401 for this time range. And now I go back to this week and go to that week again. You can see it's still there, and go to the other room. It's no booking here, and you can check over the bookings here. You can see room 405 and sorry, this one 405 in this time range. So this is the booking sites, and you can see all the bookings on the time range of that room which has been booked. You can see which room has been booked for what time range, and you can avoid and book another time. So this is the you can see also the profile here. Okay, and this is the teacher side. So now I will try a new student side. So for example, this one, you can see sign in. We don't have any account, so now I will try to sign up for this one. And like the password form like this. Okay, when we sign up, oh sorry, well, like this, and sign up. Okay, and now we go to you can see the student can see which room has been booked, but you can see that the student cannot book any room. It can see which room has been booked from in which time, but it cannot book any room. So this is the student side. So how about the admin side? Admin, we can also book room for the teacher, such as like admin. I don't know. Admin. I don't remember Okay, so this is the page for admin. So you can see the admin, they also get booked room. So for example, like this, and create admin and confirm. Now you can see the room has been booked for the admin. So this is the end of our demonstration.